Hey, thanks for clicking on my video. If this video helps you, please consider liking this video and subscribing to my channel. It is greatly appreciated and it really helps. Let's get to the video. Hello everyone, in this video we're going to talk about how we can graph sine functions. So we see at the top of our screen y equals a sine b of x. So when we see a and b there, a and b represent some transformations that are happening to the parent function of just y equals sine of x. So a we see on the left, it's a vertical stretch or shrink by a factor of a. And what this is going to do is it's going to change our amplitude, or how high or how low our sine function goes in relation to our y-axis, okay? So it changes the amplitude of the graph, and the amplitude we can find by just taking the absolute value of a. Now b, on the other hand, would be our horizontal stretch or shrink, and this is by a factor of 1 over a. So just like we looked at transformations through all different types of functions, horizontal is kind of opposite of what it looks like. So if we see, for example, a pi in the place of b, then it would actually be a horizontal shrink by a factor of 1 over pi. If we saw, let's say maybe, for example, half pi, or let's say, for example, we saw just a 1/2, right? No pi, just 1/2 for b. Well, we go, okay, that's actually a horizontal stretch by a factor of 1 over 1/2, so it's a horizontal stretch by a factor of 2. Same kind of rules we've seen with other types of functions in Algebra 1 and Algebra 2. So now, what does b change? Well, it changes the period of the graph, or the length, the time that it takes for the graph to repeat its pattern. So this is going to be 2 pi divided by the absolute value of b, because our typical period would be 2 pi for a sine function. So now, when we are graphing these, we can use 4 important points to kind of help us form our graph. So first of all, we would have the length of our period at the very end of our number line, and specifically here, just kind of like in quadrant, or when x is positive, right? And we can continue this pattern when x is negative, but we're just going to do it when x is positive. So we have our period here at the very end, and we're going to split this into 4 sections. So notice that I have my point at the origin because our sine function goes through the origin. And then we're going to do 1/4 of the period. So we have 1/4. Then we're going to do half of the period. Then we're going to do 3/4 of the period. And then our last tick mark there on our number line would be the length of the period there. Okay, so now we notice that what our y value should be. Well, we're going through the origin, so we're at 0 for y value. Then, when we're at 1/4 of our period, we're going up to a, which is our amplitude. So we're following this pattern: 0, a, 0, negative a, 0, positive a, 0, negative a, right? And we could repeat that pattern however much we wanted to do that, okay? So let's take a look at 2 examples here in this video. Number 1, we have g of x equals 5 sine of x. So we can notice, let me erase these here for us. So we'll notice that our a value is 5, right? So that's going to be our amplitude, and our period has not been adjusted, right? So that's going to be the same as our parent function, so it's just 2 pi, okay? All right, so now we can say, okay, this is a vertical stretch by a factor of 5, but we haven't done anything horizontally here, right? Because period is still 2 pi. Or in other words, b is still 1, right? We haven't plugged anything in for b. Okay, so now we need to take our period. We know this would be 0 right here. And let's put the length of our period at the very end. So that's 2 pi. Now let's split this into 4 sections. So we would have, this would be half of our period, which is pi. So then right between there would be like 3 pi over 2, and then here would be pi over 2, right? So now we can use this pattern, right? 0, a, 0, negative a, 0, a, to make our graph. So notice here that I have my 5 here and my negative 5 there. That's my amplitude. And so now we're going to build our graph. So we have a point here at the origin, 0, 0, and then we're going up to a. We're coming back down to 0. We're going down to negative a, and then back to 0. So now we can make our graph, and we can go through all of our points like this, since we know what the sine graph should look like, and we'll make our arrow going that way, right? We know that pattern would repeat, going further to the right and also to the left for negative values. All right, so that's how we would graph number 1. Number 2, we have f of x equals 2 sine pi of x. So here a is 2, so our amplitude would be 2, and our period is going to be 2 pi over the absolute value of pi, which would be just 2 pi over pi, and that's going to give us a period of 2. So now what has happened? Well, we've had a vertical stretch by a factor of 2. And we've also had a horizontal shrink by a factor of 1 over pi, right? So now we can make our graph. Well, let's go 0 here. Now the length of our period would be 2. So now let's build our other 4 sections. Half of 2 would be 1. This would be 1/2 or 3 over 2. And this would be 1 over 2. Now, once again, our graph's going to go through our origin. And we're going to have that same pattern. So 0a, so at 1/2 we're going to go up to 2, back to 0 at 1, back to, or down to negative a at 3/2, and then back to 0 at 2. So now we can make our graph. So we're going up like this to a, down through 0, through a, or excuse me, negative a, and then back up through 0. Okay, so that's a little bit about how to graph a sine function. Remember, A is our amplitude, that's our vertical stretch or shrink. B is going to represent our period, and that is our horizontal stretch or shrink. That's how you can graph some sine functions.